All right, I guess there are still some people filtering in, but let's get started. So, thank you for coming to my talk. And this is not my first time in Portugal. I've spent a bit of time in the Algarve before, but that's kind of a bit different. Like, I'm always surrounded by English and Germans and Dutch people. So, I'm told that this is the real Portugal, right? Is that right? Yeah, and it's really good actually to be surrounded by Portuguese people actually speaking Portuguese in Portugal. That's definitely a bit different to the Algarve. So my name's Adam. I am from Switzerland. I was born and raised in the UK, and I work for a company called Particular Software. We're the makers of a product called N-Service Bus. Has anyone heard of N-Service Bus? That's a few of you. That's good to see. So I'm not going to talk about that today. I will say that our company, our mission, is to make organizations better at delivering complex software systems. Now, in doing that, we speak to a lot of customers. People come to us with all kinds of really kind of difficult problems, and they're usually centered around shuffling data around, versioning components with respect to other components, rolling out components in tandem because they're coupled and that kind of thing. And it's very often in these conversations that we realize fairly early on, you know what, if the service boundaries were a bit different, if things were sliced up in a different way, if the components were shaped slightly differently, we probably wouldn't be having this conversation. The problem you came to us with probably wouldn't exist. And I think it's one of those things that's kind of at the root of the problem. So I see a lot of other problems coming out of this. So if you were to say, well, this problem causes these problems and those problems cause those problems, you end up with a kind of tree of problems. This is somewhere near the root, finding your service boundaries. So I think it's really important to talk about. Now, I may, during this talk, take some of the ideas that you're used to and a lot of the things you've read about and been taught, and I may just turn them completely upside down. Now, if that happens, that's expected. That's the intention. It may raise a lot of questions. I don't know if we'll have time for a Q&A. Before this session is finished, but I'm going to be around for the rest of the conference. My Twitter handle is in the top right, so don't hesitate to get in contact with me at any time, and I like to be challenged on this stuff. That's when a lot of the most interesting conversation takes place. So let's have a look at a system, right? Now, this is a system. Doesn't really matter what it is, right? These could be classes, they could be functions, they could be methods. But we tend to structure things in this kind of way, right? We tend to have different components calling other components. We don't just write program main and put everything in there, right? Or at least I hope you don't do that. I used to do that back in the 80s when I taught myself computing and taught myself how to program. But things have moved on since then. So we tend to create classes or functions or methods. And that actually looks quite nice, right? You can kind of tell what's going on. There's quite a nice bit of structure to it. You can tell there's some kind of area of responsibility up here. If you drill down a bit further, there's an area of responsibility here. And things kind of look quite nice. This diagram might be quite useful. Now, what tends to happen is the business will come along and they'll say, well, I was out jogging this morning and I had a great idea, right? Great new feature, we're going to make a ton more money. And you think about it and you think, well, we can do this, right? I think we can make this work. But what I need to do is I need to make a change up here, and I need some data from some kind of class down here. Let's just say these are classes for argument's sake. Now, there's nothing in our architectural constraints to stop us doing this, right? Because each class is a nice encapsulation. It has an interface. That's what classes are designed for, right? One class calls another class. So you go ahead and you just try and make the call, and things kind of work out. So you think, well, it's not messed the diagram up much. And you roll it out to production, and yes, you make a whole load more money and everyone's happy. A few weeks later, the business come along and say, well, I was playing golf this weekend, and me and the partners had a great idea. We've got a great new feature lined up. We're going to make a ton of load of money. And you think, well, we actually need to make a change up here, and we need some data from something down here. Now, the last time we did that, 3 weeks ago, that worked out okay, right? Didn't really cause any problems. So you think, well, let's try the same thing again. Let's just make this class-to-class call. We're not violating any interfaces or anything like that. And you make the change, roll out into production, you make a ton of money, everyone's happy. sooner or later, you find yourself doing the same thing again, and I think you're getting an idea of where I'm going with this now, right? Over time, and it might be a long period of time, it might be 6 months, it might be a year, it might be 18 months, you may find yourself going towards this kind of situation. Now, no one intends to do this, right? No one sets out to do this. No one wants to create a plate of spaghetti. But I've seen this happen time and time again. And the problem is that the diagram itself starts to lose its value because you speak to your colleague and you say, okay, that feature we rolled out last week, did you use a system diagram for that? And they say, that thing? I haven't looked at that in months. It is absolutely useless. So you may as well just take the lines away and just have a bunch of boxes, right? Now, individually, you look at these classes, and each class kind of makes sense. It's got a nice interface, it's got a nice name, it's got nicely named methods, and that's fine. But you want to make a change, it's really difficult to tell what class is calling what class. Right? You kind of have to go and try. Then you end up breaking something somewhere else, so you fix that. Then you break something else and you fix that. And you end up in this kind of code safari, or kind of edit and pray scenario. You edit something and pray it's going to work. And it becomes really difficult to look at these things in isolation. You can't really look at them in isolation anymore. So the diagram, again, is kind of useless. Right? You might as well just have one big box. Now, this is the point where some people call this something like a big ball of mud. Right? Has anyone seen this architectural pattern during their careers? At least a few of you. Unfortunately, I think most of the systems I've dealt with in my career, unfortunately, have followed this architectural style. Right? That's a sad truth. But the thing is, we know we can do better. Right? So we read about service-oriented architecture, we read about microservices and other approaches, and we work out that if we split this up into different services, things might be a bit easier to manage. We can think about one of these at a time, change it independently, and I've deliberately drawn very thin lines between them because we want a loose amount of coupling between them. Right? We don't have to always change 2 at the same time or 3 at the same time. We want loose, small amount of information going between these things if possible. That's great. The business will come along and they'll say, well, I was, what are we doing now? I was at a dinner party last night, and I spoke to one of the partners and we had this great new idea. We can make a ton of money with this new feature. And you think, right, we can do this. What we need is a piece of data from this service here and this service over here. And it might be something really innocuous, like a price, right? So the price of a product, 99 euros. How much harm can that cause? It's just a number. We just slightly redefine the service interface, and we can make that call. So you go ahead and you take the plunge, you make the call, you roll out into production, you're making a whole load of new money, and everyone's happy. Sooner or later, the business come along and say, well, I was doing yoga this morning, and I had a great new idea for a new feature. We're going to make a ton of money. And you realize, well, we kind of need to do the same thing again. We need to get something from this service and this service up here. Now, I'm sure you've worked out where I'm going with this as well, right? Over time, and remember, this might be a long period of time. It might be months. It might be a year. It might be more. You may end up with this kind of situation, right? It's another kind of plate of spaghetti. And as we've seen, when we're in this situation, we can't use the diagram anymore. We can't reuse the lines anymore. We may as well take them away. We may as well take the boxes away. We're back to the big ball of mud. Only this time it's a big ball of mud with a difference, because you've rolled it out on 4 machines. They're talking to each other over the network, right? And even if it's local host, even if they're on the same machine, that's a lot more expensive than class-to-class calls. You've got network latency, network outages. You've got to roll out 2 things, 3 things, or even all 4 things at the same time. Your deployment model's more complicated. You've ended up in a worse situation than you started with, right? You may as well just done the big ball of mud in one big process. And that's a shame, because service-oriented architecture or microservices was supposed to help us, but we've ended up in a worse situation by trying that. But we can avoid that, all right? So let's dig into the detail of a use case. So I'm going to talk about Amazon. Now, I'm sure that most of you have bought something on Amazon or something similar at some stage. When you buy something on Amazon, you load up your basket with stuff and you get all excited and you go, right, I'm going to place my order now. And what happens is you start a workflow, right? So the beginning of that workflow is place the order. Now what happens then is you're asked for, say, a shipping address, right? So you enter your shipping details, I want my book sent here, and you press ship to this address. You enter your credit card details, right? How am I going to pay for this thing? And so forth with shipping options and blah, 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 and all the rest of it. And then you come to the end of the workflow, and you actually say, place your order in euros or whatever. So, excuse me. Now, Amazon is a highly service-oriented company, right? There is no kind of 1 terabyte Amazon.exe, right? It is split up a bit more than that, right? It's actually a multitude of different services. You know, if you read stuff about Amazon architecture, it's fascinating. They roll out multiple times a day. It's one of the most service-oriented companies in the world. Jeff Bezos, actually, the CEO, he sent out a memo once to the entire company to say, everything you do must be service-oriented. Anyone found not to be doing that will be fired. Right? He actually sent that email. So it's very highly service-oriented. Now, let's have a look at how that might look in the back end, right? This is a slightly simplified model of the Amazon back end with sales, finance, and shipping as different services. Now, when we get to the end of that workflow, we place the order. So we send a command to sales to say, place the order. Sales does what it needs to do. So it will say, is this product still for sale? Have we got it in stock? If we haven't, can we order more? Are we allowed to sell it in this country? You know, whatever kind of thing sales does. And if that's all satisfied, it says, right, okay, I'm going to create the order in the database, you know, with an order ID, whatever. And it says, it raises an event to say that the order's been placed. Finance and shipping subscribe to that event. So finance gets a message to say the order's been placed, so it bills for that order, right? Charges a credit card. Raises another event to say the order's been billed for. When shipping has seen that the order's been placed and the order's been billed, it goes ahead and actually ships the order, right? It calls FedEx or calls DHL or does whatever it needs to do. And it may raise another event to say order shipped, which something else might subscribe to, and so forth and so forth and so forth. Now, the question is, what do we need to put on these events in order to make this work? So one way of doing it is to say, well, order placed must have all the shipping details on it, and it must have all the billing details on it, so that when finance and shipping receive those messages, finance can propagate that onto order build, or shipping can just read it off order placed in the first place, and they can all do their work, right? Because that initial event is going to contain the shipping details and the credit card details. Now, that would work, right? There's no reason that wouldn't work. But what's the problem with that? Pardon? Extending it? Changing it? Yeah, and the reason that changing it is a problem is because of coupling, right? We're back to this highly coupled situation. We're sharing data. Because just as you say, if you want to extend it or change it, right? Let's say we want to introduce Bitcoin payment, right? You don't supply credit card details. You supply whatever it is, a Bitcoin wallet address or something like that. I'm not a Bitcoin expert. What happens if you want to send ebooks? You don't send an ebook to an address. That would just be weird. I mean, I guess you could on a USB key, but that would just be weird, right? You just send them an email with a link. So if we want to start introducing Bitcoin payment or ebooks, we'll have to make a whole load of changes in sales so that it knows how to ship ebooks and it knows how to charge in Bitcoin, so it can pass the information onto shipping and onto finance and so forth and so forth. And then if you look at that event, you're going to have all kinds of weird nullability rules like, oh, well, either the shipping address has got to be not null, or the email address for the book has got to be not null, or the credit card's got to be not null, the Bitcoin not null, and you end up with this kind of nullability soup, and the event is getting fatter and fatter and fatter and fatter, right? We've got a big fat event with loads of stuff on it. And that means we have to roll out these services all at the same time, and they can all talk to each other about new information. Now, what if we take that fat event and we slim it down to a very thin event? What if we can slim it all the way down to just an ID? Literally just an event saying order placed with an order ID on it, like order 123 or a GUID or whatever it needs to be. What can happen then is Sales can say, order's been placed, and the order ID is 123. Finance can say, order 123. I know how to bill for that, and it goes and charges a credit card, or it goes and charges a Bitcoin address, or whatever. Shipping says, the order's been placed, the order's been billed, the ID is 123. I know how to ship order ID 123. And it goes and sends it to a physical address, or it sends an email, does whatever it needs to do. That sounds great, but the problem is that we've got a kind of chicken and egg problem here, right? Because sales is creating the order, right? It's creating the order ID in the database. So how can finance possibly know about order ID 123 before it's received the event? And the same with shipping. How can it know? Now, until now, we've assumed that the order ID is going to be created at this moment, right? Now remember, that's the end of the workflow. What if we turn that upside down and we say, let's create the ID at the beginning of the workflow? So you can actually create it here when you say proceed to checkout. When you say proceed to checkout, before you go through that whole workflow, you already create the order ID. And you can even do this client side, right? You can set a client side order ID as a GUID. What happens now is we go into our workflow. When we get to here, we already know the order ID. When we click ship to this address, we actually send a message to the shipping service to say this is the address for order 123. When we go to the credit card details, we already send a message to the finance service to say these are the credit card details for order 123, right? Or the Bitcoin address, or back here, this is the email address for the ebook, and so forth and so forth and so forth until you get to the end of the workflow, right? You click that button. And now, this command comes in, and when finance receives order placed, order 123, remember, we've already told the finance service what the credit card details are for order 123. We've already told the shipping service what the credit card details are, what the physical address or the email address is for order 123 during the workflow, right? Now, we can slim down that event to just an ID, because those services are sitting there ready with that data already, right? Very, very low amount of coupling. And the weird trick that's allowed us to do that is to create the ID up front instead of at the end. Now, you may be thinking at this point, well, that's all well and good, but what if someone never gets to that point? What if someone never actually says place your order? They filled in all these details, blah, 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 and then their wife or husband walks through the door and they get a guilty feeling and they kind of close the browser and say, oh, well, I shouldn't be spending that money after all. Now, shouldn't something come along and clear up that data, right? We've got this redundant rubbish sitting around the database. But is it really redundant? Is it really rubbish? Now, isn't it interesting to know which orders went to completion and which didn't? Is there some kind of trend we can spot there? Is this certain group of products going to completion and this certain other group of products not going to completion? Can we A/B test that? What can we do to improve that conversion to actually clicking the place order at the end? This is really rich business analytics, right? A lot of businesses would kill for that information. So ask yourself, is it actually redundant? And it doesn't necessarily have to be in a database. I mean, if it is, it's just a row in the database, right, which is pretty cheap to store. But you've got to be careful about holding credit card details, right? So that could just be in session state, right? The user closes the browser, the session expires, and the data goes. So don't worry too much about redundant data, which, as you can see, in many cases is not redundant at all, actually very valuable. So this is what we ended up with, and why did we end up with that? Well, it's because it all started here, right? It all started with the sharing of data. So now we can start to define kind of what a service is. But first of all, what a service is not. A service is not something that is just kind of something with functionality, like a validation or a calculation or something like that. That is what a function is, right? That's kind of the definition of what a function is. It's not something which gives you CRUD operations on data, just changing records. That's what a database is. And really importantly, if you just put HTTP on top of a database, just sprinkle this kind of magic ASP.NET Core magic dust over a database, it doesn't suddenly make it a service, right? Contrary to a lot of the articles that appeared on the web a while ago, it doesn't suddenly make it a service, right? All you've done is, it's still a database, you've just changed the technical entry point from database connection to HTTP. A service is the technical authority for a specific business capability. And really importantly, all data and business rules reside within the service, right? You can think of it as bounded context, if you like, if you're kind of an Eric Evans domain-driven design fan. And equally importantly is that nothing is left over. After you identify your services, service A, service B, and service C, it's not that you then have this other stuff on the side. It's kind of, oh, we don't know where to put that, so we'll just kind of chuck it to the side somewhere. You need to place everything in some kind of service. Now, if you think about it, the code that we write is for some business purpose, right? We don't just write code for fun. Although, if your project's failing and you know it's going to fail, then I forgive you for going and learning Rust or something. But under normal, ideal circumstances, we're writing code for business purposes. And if the service is the technical authority for any specific business capability, that leads us to the fact that all code must belong within some kind of service. And it's really important because when you find that stuff that's really difficult to place, that's when you ask and answer the most difficult questions. And that's where those service boundaries start to get really crisp and start to get really defined. So if you have this escape hatch of other stuff left over, you avoid that, and you avoid the benefit of asking and answering those really difficult questions. If you look at it in terms of systems, so sometimes it's very tempting to build or to name services after kind of systems that exist. Has anyone ever heard the term backend service? Right? I've heard that a lot of times in my career. This is the backend service. This is the front-end service. But the thing is, these are technical concerns, right? Services are logical concerns. They kind of cut across these things. Now, the implication of that is that you may have a service which ships an Objective-C component, or Xamarin, or whatever it is these days, a .NET component, and a Java component. You may have a system which consists of components from Service 1, Service 2, and Service 3. It's kind of like, when you play with Lego, and you have that kind of green board, and then you might have piles of bricks. And I was very kind of specific about this when I used to play with Lego. I used to have like red bricks, yellow bricks, and white bricks, or large, medium, and small. And I kind of pick a brick from each pile, put it on the green board, and build something, right? Think of those as your services. You're taking bits from each service, putting it onto the green board, and building a system, which might be a mobile app. Services are logical design time concerns with business-aligned boundaries. Systems are physical runtime concerns with technically aligned boundaries. Okay? Services, logical design time business. Systems, physical runtime technical. Now, if there's one thing I want you to take from this talk, right, it is this thing that logical does not equal physical. I think the conflation of the logical and physical, it's even, if you think about that tree of problems, it's even a step below finding the right service boundaries. Because so many times I've seen the wrong service boundaries used because the logical gets conflated with the physical. Right? That's something that is kind of a little bit endemic in the microservices literature, is that the physical microservice is also the logical service. I'll come to that a bit more in a minute. But as I say, if there's one thing I'd like you to take from this talk, even if you're just going to kind of zone out for the rest of it and go on Slack or whatever, it's logical does not equal physical. So let's have a look at a bit more of a concrete example. Now, you might speak to the business, and they might say to you, okay, we've got customers and products, right? We sell products to customers. Let's start there. So the first thing you do, you get around the whiteboard, and you draw a box for customers, and you draw a box for products. And they start telling you about the details. And you say, okay, well, that's interesting, but let's get into the detail a little bit later. Tell us more about the high-level concepts, right? So you start drawing more boxes. And then you end up finding out that a customer has a first name, and a customer has a last name. Customer has a status, product has a name, description, and a price. And the interesting thing about this is that businesses often don't know what they want, but they almost always know what they don't want. And you can take advantage of that. You can ask really dumb questions. You can use a technique which I call anti-requirements. And anti-requirements involves asking silly questions like, if the customer's first name begins with an S, does that affect their status? Now, at that point, you're going to get some puzzled looks. And so, you what? You really have no idea about this domain at all, have you? That is so dumb. Not only would we never do that, no one in this entire industry would do anything so stupid. Now, don't be afraid when that happens, because you've just struck gold. Because what have they just told you? They've just told you a stable business rule. They've just told you that there's no relationship with a customer name and their status. So, why are they in the same box? I'm not seeing a good reason for them to be in the same box right now. I'm going to put them in separate piles, right? I don't really know what these things are just yet, but I think I see that customer status has no relationship with customer name, so I'm going to put them in two separate piles. And at this stage of modeling, this is what you're trying to do. You're trying to create different piles of stuff, different piles of related stuff. And these are not, this is not a class or a row in the database or anything like that. This is a logical modeling exercise. We're just putting logically related stuff in the same pile, and we're going to see how that works out. Then we see that customer status, well, it's kind of sitting there on its own, looking a bit lonely. So what is the point of that thing? What is it there for? And the business will say to you, well, we use that to work out how much to charge the customer. So if they're a gold customer, they get 20% off. If they're a silver customer, they get 10% off. Everyone else pays full price. Okay, so you just have price, right? So customer status has got something to do with price, right? Okay, so let's try that on for size. Let's put them in the same pile, right? They're somehow related. And then you think, well, what have we got left over? We've got the product name and the description. Well, they kind of go together, right? If something is a deluxe something or other, you want the description to tell you why, right? And why it's so great and why you should buy it. So you put those in another pile down here. Now, that's led us to a very different model. Again, this is a very simple example, but you can imagine more complex examples. You get a radically different model than you would have with the kind of entity approach. And this is actually quite tough because our kind of brains and eyes are wired to look for tangible things, right? Tangible, nameable things. So it's kind of like, it's a bit counterintuitive, but one of the tricks you can use is to watch out for, when you hear something like customer has a first name, look out for that bit in the middle, has a. As soon as you hear has a, that's an alarm bell. It's an alarm bell to say that you're going down a kind of entity-first high-level approach instead of looking at the use cases. Modeling is about behaviors and scenarios. It's not about tangible things. Has anyone read Eric Evans' Domain-Driven Design book? That's quite a few of you. So if you were like me, you read the first half of the book, you got really excited, you ran to work, and you started writing value objects, entities, and aggregate roots. That sound right? I see a few smiles. I see a bit of familiarity with that. Now, Eric said later on that he wished he'd put that in the second half of the book. Because a lot of people read the first half, get all excited, and don't read the second half, right? I read the second half eventually. And then later on he said, well, I wish I just put the entities and stuff in an appendix. And later on he actually said, I wish I left it out altogether. Right? Because it distracted people so much from the more important lessons which were in the second half of the book. Now, I'll either go ahead and say it, in this context, as a modeling tool, entities are bad. Right? And I know that goes against a lot of what you've seen and heard, right? But I truly believe that entities are bad as a modeling tool. Behaviors and scenarios, great. You need to look into the detail. You need to look into how the data relates to each other, what actually takes place in a typical use case in scenarios in the system. Another good thing here is to not give these things names too early, right? I often say just give them dumb names like red, green, and yellow, or names of planets, or names of cartoon characters. It doesn't matter. you might look at this and say, well, that's clearly customers, that's clearly products, et cetera, et cetera. But the problem is, if you name things too early, those names cause two problems. First of all, they mislead you. So you have a conversation around the whiteboard with your domain expert, and you say, well, that's clearly billing, right? And you put it in billing just because it's called billing. Or you say, well, that can't possibly belong in there because that's marketing, right? So you don't put it in there. You want to put it in there, but the name's stopping you, right? So don't name these things too early. In fact, I was working in a team once where we just decided to never give these things meaningful names. Right? We actually use kaiju monsters, so like Godzilla and Godzuki and Udaku and Mothra and other more obscure ones. And we just left them with those names forever, right? Because they're kind of, it's a bit of an abstract domain. Those names are not going to really add, meaningful names are not going to add anything. So we just left them called kind of meaningless names forever. Now, insurance is another kind of interesting domain in this context. Does anyone here work in insurance? 1, 2, 3 lucky people, right? So insurance, and tell me if I get this wrong, right? But insurance is largely based around kind of a front office model and a back office model. So you get people selling policies in the front office and people dealing with claims in the back office, right? And the front office is actually all about fear. Right? It's about making people afraid enough about bad things happening that they're going to buy insurance. And actually, I was in Russia talking to some people about this once, and they told me that the Russian word for insurance actually has the word fear in it. Right? So there is some truth to this. Now, the back office, on the other hand, they're all about paying as little as money as possible when a claim is made. Right? Have I got that about right? Yes. You're nodding your head, so I guess I have. Sounds a bit cutthroat, but really, that's the model of any business. It's maximum money in, minimum money out. Now, a colleague of mine was actually called into an insurance company essentially to look at their service boundaries, to say, have we got this right? And what they showed him was this. They showed him a policy service, which kind of represented what the front office do, and a claims service, which just kind of represents what the back office do. Now, I know next to nothing about the insurance industry. I have no idea how to run an insurance company. But I can look at this and I can say almost straight away, this is wrong. The reason for that is think about a typical use case. What happens when you make a claim? You send it off, you send off a form, or you might do it online. The claim service receives that. What's the first thing that they do? They start reading the small print. They go to the policy service, get the entire policy, including pages and pages of small print, and they go through it with a tooth comb and work out, A, if they can get away with not paying, or B, how little they can pay. That's a whole load of request response between those two services, right? They are very, very tightly coupled. Now, it's all very good saying it's wrong, but if you're called in as a consultant, they want to know what's right, okay? Now, this is tough, right? So when you're trying to find the right service boundaries, it's often a very stressful exercise. You kind of find yourself kind of bumbling around with your eyes closed, bumping into stuff, and you've really got no idea what you're doing. And it can take a while to get that flash of insight. 3 or 4 days later, time passes and the management say to you, well, you told us it was all wrong. Have you found out what's right yet? You say, well, yeah, I'm getting somewhere, even though you're actually not getting anywhere. But eventually, hopefully, you get that flash of insight, and this is what it tends to be like. And you realize that in talking to the domain experts about all the typical use cases, you realize that home insurance doesn't actually have much to do with travel insurance. And travel insurance doesn't have much to do with car insurance, because when I crash my car, I don't show them my sofa, right? Or if my cat chews up the sofa, I don't show them my cancelled plane ticket, right? They're very disparate things. So you draw these kind of service boundaries. You draw around home insurance, around travel insurance, around car insurance. You think, okay, I might have something here. I might just have something here. You examine the use cases, you realize you don't have request response going between them, and you think you might be onto something. So it gets to Friday, you've just made it in for the end of the week. You book the biggest meeting room in the building, you call all the senior management together, you get a beautiful PowerPoint presentation together, and you stand up and you make your world-shattering announcement. Home insurance is different to travel insurance. Travel insurance is different to car insurance. And the business look at you and they say, how much have we paid you to come in and tell us something that we've known for our entire careers, something that the industry has known for 100 years? Now, again, you've struck gold, because what they're saying is, yeah, but that's obvious. If you hear something like that, but that's obvious, we know that already, that's a really, really strong sign you've got things right. Now, you might think, well, why did we waste that entire week having all those meetings and all those whiteboard sessions and me getting stressed and drinking 1,000 cups of coffee? Why didn't we just ask them in the first place? Why didn't we just say to them in the first place, how is it organized? Well, the problem is, that's obvious, right? But so is that. And there are a myriad ways of describing this business, right? It all depends on who you talk to, what their context is, what their job function is, what their motivation is, what they're aspiring to. You might get lucky, right? You might just get lucky. And some might say, oh yeah, we've got home insurance, travel insurance, and car insurance. Those are our service boundaries, off you go. Or they might say, we've got a front office and a back office. Or they might say, we've got products, customers, something else. Again, it's not a top-down exercise. It's not drawing the big boxes first and then looking at the detail. It's a bottom-up exercise, right? It's looking at the use cases. It's looking at the data that's involved in the scenarios that will lead you to the better model. And again, that goes against our intuition. We usually want to see a 30,000-foot view first and then drill down. It's the other way. And people often say to me, well, do I really need to go into that level of detail? Do I really need to start looking at the use cases and going into all and exploring all of that nitty-gritty stuff? And the answer is yes, right? And it's not a cheap way of working, right? It's an expensive exercise because it takes time, it takes effort. But that's the way the model reveals itself. Bottom up, not top down. Now, that's a kind of specific example of organizations, right? So organizations are typically split into departments, right? Departments, divisions, teams, whatever you call them, organizational units. And it's really tempting to come into an organization, and when you see, oh yeah, we've got a marketing department, we've got a finance department, we've got a sales department, okay, great, let's just draw our service boundaries around those and off we go, we're done, right? Now, that may have worked at one time. If you think back to before we put computers on everyone's desks, right? Before the age of computerization, data existed on paper. Paper existed in filing cabinets. Now, the cost of data access was expensive. If you were sitting in one end of the building and you needed papers from a filing cabinet on that side of the building, on that side of the building, right over in that corner there, that's a very, very expensive method of data access. So what you did was you surrounded yourself with the data you needed, right? So the filing cabinets containing the papers that you need were sitting around you. And then you get a kind of request to do something in, and you kind of go to your filing cabinet, get a piece of paper out, you fill out a form, put it in your outbox. Someone will come along with a trolley and kind of move it over to someone's inbox. They go to their filing cabinets and get the information that they need. They maybe tick a box and put it in their outbox and so on and so on. So organizations were almost forced to be service-oriented. Right? A department would basically encapsulate a business function and the data required for that business function. And at that time, that might have been a useful way to start looking for service boundaries. Then we came along with our fancy databases and our fancy computers. We put a computer on everyone's desk with a big fat database in the middle. And all of a sudden, data access is really, really cheap. Basically, anyone in the company can access any data they want, right? It's just a matter of setting a security flag, which is often a case of knowing the right person. So what's happened is managers have taken advantage of that. Managers are, in most large companies, motivated to build their org structure, right? The more boxes you have underneath you in the org structure, the more likelihood you're going to get a higher bonus and you're going to get promotion. So managers kind of pick and choose jobs from around the organization. Have you ever seen a manager leave and then the other managers kind of fight over the scraps to take over job functions? I see a few smiles, so I've seen that a few times in companies that I've worked in. And the problem with that is it's not a stable business abstraction, right? We want stable business rules for our boundaries. First of all, it changes very often, right? I worked in one company where my org unit used to change 6, 7, or 8 times in a year. So if you're modeling around that, you're going to be changing your code and ripping everything apart all the time. And the other thing is it doesn't really represent the business. It really represents a manager's skill at empire building, because the modern department has become a kind of like mini kingdom, right? Or mini empire. So it's really not a useful tool in most cases for drawing service boundaries. So beware the organizational structure. Now, I did promise to talk a little bit about microservices. Now, I think a lot of great stuff has come out of the whole microservices movement. So we've got great stuff around independently deployable units, elastic scaling, and we've got things like containers and Kubernetes and all this kind of stuff, and that's all really great. However, I do have one big concern about this, which I'll try and illustrate. Now, microservices are another kind of thing in our toolkit to battle against this nemesis of ours, a big wall of mud. This is what we're trying to avoid. So we read about microservices, and we see that we really need to split things up into smaller units. So we split things up into, say, 5 microservices, and things are already looking better, right? We can look at each of these things in isolation. We've got nice small lines of communication between them, and things are looking quite good. Then we read another blog post, and it says, well, you should really have at least 10 microservices. 5's not really enough. So you split things up a bit more, and you end up with, 13 microservices here. And you think, okay, well, we must be doing microservices now, right? They're all nice and small and independent. Then you read some more literature, and it says, well, each microservice should really be rewritable within 1 week, or even worse, it should be 300 lines long or no more, or something like that. So you split them up even more, and you end up with a whole bunch of microservices. Does that look familiar? Kind of deliberate. And it's looking quite nice, right? But the business come along and they say, well, I was out drinking last night with my buddies, and I had a great new idea. We've got this great new feature idea. We're going to make a ton of money. And you think, well, we actually need to make a change up here, and we need some data from down here. And again, we haven't imposed any other architectural constraints at this point, right? Each microservice has a clearly defined interface, which if we respect, it should not be a problem to make that call from there to there. That's what they're designed for, right? So you make the call, you roll out into production, you're making a ton of money, and everyone's happy. Sooner or later, they come along with a great new idea. They were out, I don't know what they're doing this time. I was at a football match, I had a great new idea. And you find yourself doing the same thing again. We need some data up here, and we need some data from down there, so you make the call, and you've seen this before already, right? Over time, and remember, we're talking long periods of time here. We're talking maybe 6 months, a year, 18 months, maybe longer. You may end up with this kind of situation, which you've already seen before. We've seen we may as well take the lines away, we may as well take the boxes away, and we're back to the big ball of mud. Only this time, it's a big ball of mud with a difference. We've rolled this out into 100 Docker containers. Right? We've got this amazing, amazing deployment pipeline where we can deploy all of them at the same time, because we usually need to. Right? Because they're so tightly coupled. They're all talking to each other over the network. Network outages, yeah, they do cause a few problems now and then. So you've ended up with a big ball of mud, microservices edition. And again, this is a real shame, because microservices were supposed to help, right? We introduced these with all the best of intentions. It was supposed to help us. It was supposed to make things better. Unfortunately, it's kind of backfired. We've ended up in a worse situation than we started with. Now, again, what we want is a smaller number of logical services, right? These are logical boxes. These are not physical boxes, right? With small amounts of information going between them. Ideally, just IDs, as we've seen. Now, within those, we have different components, right? We've already seen how we can take something from each service and ship it into a system, right? So we might have a Xamarin component shipped by each of these three services. We take those three Xamarin components, we put them into a mobile app, we package it, deploy it, and it goes out to people's phones, right? That's a separation of the logical and the physical once again. Now, within these services, again, you might look at these individual components and say, well, are these not microservices within these logical boundaries? So these are logical boundaries. These things in here are actual physical components that we build. Could we not call those microservices? Well, you could, but I prefer to call them autonomous components. I don't really like the word microservices for two reasons. Micro, right, which implies that small is important, and it is not. And service, right? It's another overloading of the term service. And it's highly distracting from services in the service-oriented architecture context, where services are logical concerns. And what I've seen happen too much within the microservices movement is too much conflation of the physical with the logical, right? Where that's the only architectural constraint. We've got our nice physical boundaries, and we forget about the larger logical boundaries. And the thing is that we split things up within these logical services for a very different reason. Imagine that this box down here is something to do with bank accounts. And two of its responsibilities are creating bank statements and locking accounts for fraud. So if we suspect there's some kind of fraudulent activity happening on an account, we send a message to this service to say, lock this account, and that needs to happen instantly. Right? The business will say to you, that needs to happen right now, within milliseconds. Right? Bank statements, you know, they just need to happen sometime today. You know, occasionally, if they're a day late, it's not the end of the world. So what we do is we separate those two responsibilities into two separate autonomous components. We have a component for bank statements, and we have a component for fraud. The component for bank statements, we might put that on, I don't know, two VMs for high availability. You know, if one falls over, the other one takes over, you know, whatever. Fraud, we might roll that out onto 10 machines, all competing off the same queue, or elastically scale it, or do all kinds of crazy stuff, like get all kinds of container orchestration involved, right? That might sound familiar for what you've read about microservices, right? And that's where a lot of the things in microservices really come into their own, around these individual small deployable units. So we split these things up for very different reasons. And you might think, well, isn't it possible to build a mini ball of mud, right? So this one down here is starting to look a bit complex, right? So isn't that possibly becoming like a little ball of mud of its own? Now, I'm not going to say that's impossible, right? With enough determination, you can make a mess using any architectural style, right? But I will say it's less likely, because as I've demonstrated, we split these things up within these logical boundaries for a very different reason to the top level split which we saw earlier. We split them up for different levels of SLA. We split them up to ship them into different parts of different systems. So yeah, as I said, call them microservices if you want, but I just don't like that term. Right? I prefer autonomous components. So we're coming to the end now. I've really just scratched the surface here. You know, if you want to know more about this stuff in a lot more detail, this is a guy called Udi Dahan. He's the CEO of our company, and the creator of Ren Service Bus. He runs a 5-day advanced distributed systems design course. And this is actually an in-person course that happens, I think, 4 times a year. It's also available as videos. Now, what I've done here is I've put together a package. This is go.particular.net/ndc-porto-2019. If you miss that, just tweet me and I'll gladly supply you with the URL. I've put together a package for you, which is an extract of those videos, and that's completely for free. So just follow that URL, grab that video package, and you'll hear a lot more about service boundaries and SOA in a lot more detail. So I'm just going to finish off with saying that has anyone read the Gang of Four patterns book? Yeah, that's probably at least half of you. So, do you remember when you read about that next pattern and you rush into work the next day and implement it? And then the way you wrote your system was the last pattern you read about, and in the end you're kind of using all these patterns because they're really exciting and you really want to. Now, I know I did that, right? But this, again, is not a silver bullet, it's not a golden hammer, it's not something to be used in all circumstances, just like anything in software. Now, does anyone here work in a startup or a startup-ish kind of environment? Yeah, so just a few hands going up. All right, so for you guys, I've got a little bit of bad news, right? If you're getting excited about this kind of stuff and you think this is interesting, be very wary of using it too early in a startup phase. So the problem is that startups are a very good example of where you might not want to use this, at least initially, because startups don't know what their businesses are yet, right? It took Facebook quite a while to realize it's actually a media company, right? Facebook puts eyeballs in front of media, it sells the eyeballs to advertisers, right? That's a media company. Although Facebook doesn't actually create the content, the eyeballs create their own content, so it's very lucrative. I think that's part of the reason they're worth so much money. Twitter took them a while to realize how they were going to make money, and they ended up rewriting their system completely. Now, when in the early years of a startup, you've basically got a whole load of great ideas, you've got them spread out on the floor, and you're just making a mess and trying to find out how you can make something work. Now, my advice there is just write whatever code you need to do to prove something. Write whatever code you need to do to make something work. And you might say, well, but we're going to have to rewrite it, right? Because it's going to end up in a mess. Well, yes, but if you started modeling your service boundaries around those initial ideas, when you actually discover what your business is, you're going to have to rewrite it, right? So you're going to have to rewrite it either way, in the vast majority of cases. So be very wary about using this too early on in a startup scenario. As I said, it's not a cheap approach, it's an effortful approach that requires looking at a lot of detail, a lot of scenarios, right? So it is an investment. It is a not inconsiderable investment. So I think we've actually got a few minutes left. So before I wrap up, has anyone got any questions they want to throw at me at this time? Yeah. Okay. Okay, so the question is, for each of those autonomous components within a logical boundary, do we actually segment the database, or do we share a database between the autonomous components? And the answer is, you do whatever makes sense for that service, right? Because when you're operating within a logical service boundary, as long as that service boundary is encapsulating all the business rules and all the data, and it's not revealing any data outside to any other services, you're within your architectural constraint. Now, for some services, and actually if we go back to that diagram quickly, you'll notice that this service here, the physical boundary just happens to align with the logical boundary, right? There just happens to be a one-to-one relationship between the physical and the logical. But it's just coincidental, right? It just happens to be that that makes sense for that service. It's not by architectural constraint, which unfortunately is what a lot of the microservices literature says, is that a service equals a deployable unit equals a logical unit. Now, in the same way, it may make sense for these components here to share a single database, or it may not, because you're going to get row-level locking contention on creating bank statements and locking accounts for fraud, right? So, and this is one of the interesting things. Once you get very solid business-aligned boundaries for your services along stable business rules, to some extent you can kind of go to town within that service boundary, right? You can use a radically different technology for these backend components here to these backend components here. You know, you can use Ruby in one and Java in the other, or Python in one and .NET in the other. You know, you can kind of just do what makes sense for that service. So the answer really there is do whatever makes sense for that service, right? If these things can cooperate with each other within the database, fine. If not, split them up. But it's really your choice because you're already operating within the confines of that logical boundary. Does that answer the question? Yeah. Any other questions before I wrap up? Yeah.
You said that within a service we should only exclude the ID, but inside the logical boundary of that service,
Mm-hmm.
the different autonomous components can expose more information between them.
Okay, so the question is, between services, all we do is share the ID, but within a service, the autonomous components can share more than just an ID between them, right? And basically, that is a correct statement, right? So there are public events and there are private events, right? So public events will be what we've seen before in the Amazon example, where we've got an event being published from one service to another service, right? That's a public event. The service is actually publishing those events. Within a service, you might have an event-driven architecture, which also relies on events, but because they're all within one logical boundary, they are at liberty, if they want to share more data on their events. You know, those are what I would call private events. And there you can kind of do whatever makes sense for the event, for the service as well. It's actually quite similar to the last question in that if that makes sense for that service, if it makes sense for these autonomous components to be publishing events with more data on them to each other, then yes. Although commands versus events is kind of another very big subject. Events, so you wouldn't really send commands from one service to another. You'd only publish events with IDs on them. Commands tend to have all the information that is needed to perform that command on them. So you would send commands within a service, but only publish events between services. But that's a kind of whole nother topic, which unfortunately we don't have time to get into. Okay, so as I said, I'm going to be around for the rest of the conference. Please do approach me at any time and challenge me on this stuff. That's when most of the really interesting conversations happen, when I get challenged on this and people say to me, well, how can that possibly work? And we can have some really interesting discussions. My Twitter handle is up there on top right. Do tweet me as well. I can open up a DM channel, and I really enjoy discussing this stuff. So please don't hesitate to approach me. So I hope you've enjoyed that. I hope you're going to find it useful. I've really enjoyed talking to you, and enjoy the rest of the conference. And thank you very much.